Here we are looking for the range of sample means that define the middle 95% of the distribution of sample means when we have an n of 25, and that's selected from a normal distribution with a mean of 50 and a standard deviation of 20. Again, start by what it is that you know. We have 25 people, our population mean is 15, our population standard deviation is 20. We're looking for the middle 95% of the distribution. So again, let's see, what does that visually look like? The middle 95%, so that is everybody in here. If we have 95% here, then we know we have 5% on the outside, right? Since we have two outsides, we have 2.5% here and 2.5% here, because this plus this is 100%. That's everybody, right? And then we know if this is percentage, it's very easy to make proportions out of this. So the 95 proportion is 0.9500, 2.5% proportion, and you just divide it by 100, that's how you get it. It's 0.0250 on this side and 0.0250 on this side. So this is what it visually looks like. And that is actually the same as having an alpha of 0.05. But if you forget what the C-score is for that, you can always look it up. So you're looking for a C-score, right? Because you need the C-score for this and you need the C-score for this in order to find the middle 95% that's asking the question. You can always look it up. So you can look up what is the C-score for a proportion of 0.0250. And that's in the tail, right? And then you see that in the tail is this row right here, and we see that is corresponding to a C-score of 1.96. But you can also remember it, right? Because we only have 3 alpha of 0.05, 0.01, and 0.001. But just in case you forget, you can always look it up. So proportion and tail, 0.0250 corresponds to a C-score of 1.96. So this right here is 1.96 below the mean, and this is 1.96 above the mean. So now we're looking for a range, right? Because we're looking from here to here. So that's the range right here. And now we just do our calculations. First we write our formulas down. So that is our C formula, m minus the population mean over the standard error of the mean. And for that the formula is the standard deviation over the square root of the number of people. So now we just plug in 20 over the square root. We said our n is 25. So that's 20 over 5. That is a standard error of 4. And in this case now, we just have to, let's see, we have the C-score. We know that's 1.96, one positive, one negative. We know we have this, the population mean is 50, and we know the standard error of the mean, we just figured out, is 4. So we're solving for two m's. We need an m for positive 1.96 and for a negative 1.96. That was the other way around, but you get the idea. So now we're just solving for m. So let's plug it in. Let's do the positive first. 1.96 equals, m is what we don't know, so that's the value we're looking for. Then we plug in 50 over, and we said this is 4. So now both sides times 4, right, in order to isolate m minus 50 on one side. So that is going to be 7.84. Now we left with m minus 50. Now we add 50 to both sides. So 1m is going to be 57.84. And that's a positive one, so this is this one right here. Right? So a C-score of positive 1.96 corresponds to an m of 57.84. Now we have to do the whole thing for this one right here. So let's do it in blue, just because it's getting kind of messy here. So again, we are solving for negative 1.96 C-score. M is again what we're looking for, and this stays the same. That's 50 over Standard error was 4. Now we multiply both sides by 4, and now we get negative 7.84 equals m minus 50. Now we add 50 on both sides, and now we get 42.16 equals m. So that is for this one right here. So the range then of the sample means that defines the middle 95% is 42.16 to 57.84.